Let's talk about integer exponents. That's going to be covered as today's topic. Let's first go over some laws of exponents. Some of these you've seen before in previous sections, and some of them are new. So let's talk about them. Law number one here says that if I multiply two numbers or two items with the same base, and they have different exponents, I can simply add the two exponents together. We have seen this in a previous section. Number two says if I'm dividing two items with the same base and they have different exponents, I simply subtract the exponents. Law three, and if I have something being raised to a power, if I have an exponential raised to a power, then I can just simply multiply these two numbers together. We've seen that one. Fourth one, we've seen this one. We can distribute this in. So this becomes a to the m times p. And this becomes b, this should be to the n times p. b to the n times p. That's number four. We saw that one last time. Okay, a couple of these here, kind of new here. If we have anything raised to a 0, then that's equal to 1, with the exception of 0 to the 0. That's not defined. But anything other than that, raised to the 0 power, let's say the 0th power or something of that nature, that's equal to 1. And then the last one here, anything that's raised to a negative power, you can basically put it on the bottom and make it a positive. You can take its reciprocal there and make it the positive power of that. Let's look at some examples of these. Make sure you have these written down somewhere. You're going to use these all the time in this particular section. Here's some basic examples that we'll cover that go over a few of those laws that we just saw. The first one we've seen an example of. This is a multiplication of two things of the same base. We simply add the exponents. So this becomes 7 plus 3, like so. And this gives us x to the 10th power. All right? Let's look at the next one here. Division of the same base with the exponents. If you remember just a minute ago, the laws stated for this particular example, we subtract the exponents. Okay, so that would give us y squared. Remember, if you're not clear on this, just go back and look at those laws and you'll see that I'm just using them to do that. We said something earlier about everything raised to a 0 power. This is equal to 1. And of course, z can't be 0 here as we explained. And finally, something raised to a negative, we put it on the bottom over 1. And make that exponent now positive. Now these are very basic examples, but what you're going to see is these problems get very complicated or they look complex. But the good news is we can always make them and break them down into simpler versions of the problems. And if we understand these, we can solve any problem that we see. So let's now look at a few more complicated examples. All right, here's a couple of more complicated examples that we can look at. Let's start with the one on the left here. Now, there's a lot going on, but let's break it down into simple versions of problems that we just saw a minute ago, the basic examples. When we're doing multiplication here, we can change the order of things. I've discussed this before. But anything that I'm multiplying, I can move it to the left side or to the right side. It doesn't matter. 2 times 3 and 3 times 2, those are equivalent. So what I'm going to do first is I'm going to change this bottom part, the order in which this is being multiplied. I can swap orders like that when it comes to multiplication. The reason I've done this is now look what we have. If I covered this up, you know how to solve this problem. And if I cover this one up, you know how to solve that problem. It's just two of the basic problems that you saw put together. So here, we're dividing x's, so we have to subtract. -4 minus 3. Okay? And the same thing goes, let's put this down here so it's a little bit bigger. -4 minus 3, okay? So this is -4 minus 3. Pay attention to your negative signs. All right, and the same thing goes here. We have a division, y to the 6 minus 2. Now, let's simplify this by adding and subtracting what we need to do here, the exponents. This gives us x, now -4 minus 3, that's -7. 6 minus 2, that is 4. Okay, now we're almost done. We need to get rid of the negative exponents. If you recall, we can make the negative exponent go to the bottom and change it to positive, and that way we'll be good to go. So finally the answer is y to the 4th over x to the 7th. Notice I just brought this down here and made these 7 positive. So what we've done is we've taken something that looks a little more complicated, broke it down into simpler examples, and then just solved it like we did earlier. Let's look at this one now. Okay, so this one, we have to first distribute in this exponent according to one of the laws. If you look back, it's the 4th law that we talked about in just a minute ago. So this gives me x to the -6, y to the positive 12. This -6 came because -3 times 2 is -6. This 12 came about because -3 times -4 is positive 12. Now, what do we have to do with negative numbers? We have to bring those numbers down to the bottom. Okay, so we bring that down here. So doing so leaves us with y to the 12 over x to the 6th. Okay, and that will be how you solve this particular type of problem. Now let's go into one that's even more complicated than this, or looks more complex. They're all basically the same thing. Okay, so here's an example. Has a lot more going on, but let's see what we can do to make this simpler. Let's see. Well, I can break this up. So notice what we've done. We just kind of put spaces in between these lines, pretend they're all connected. But look, it's just 4 individual basic problems, that the first ones that we had. So let's look at this part first. Here we have 24 over 36. Now we need to reduce that. What I can notice from this is that we can divide the numerator and the denominator by 12. So 24 divided by 12, and then 36 divided by 12. All right? Now that gives me 2, and this gives me 3. So this part here we can reduce to 2 over 3. All right? Let's look at what we have here. We have a division of the same base. That means we subtract. So this is a 2 minus 7. Now let's look at what we have here. Again, we have division, so we subtract. B 7 minus 5. And finally, the same thing we have here is division, so we can just subtract them. C 9 minus 2. Now let's figure out what our exponents are going to be. 2/3. A to the 2 minus 7 is -5. 7 minus 5, that's 2. And 9 minus 2, this is equal to 7. Now we're almost done. The key here now is we're going to have a fraction, because we have this 2 over 3. Let's put the bar all the way back. Whatever we have on the bottom, so we have a 2 over 3 here. Now, so that's 2 over 3. Whichever things are negative, we put on the bottom, and whatever's positive, we keep it on the top. So, we have an a to the negative 5. That goes down here. That goes down here. And we have a b squared and a c to the 7th. Those are positive. Those stay up here. All right, and then we can kind of shorten that up. So there we go. That's basically all you have to do. Let's make this look a little clearer. This is negative 5. Oh, I'm sorry. This is 5 now. Okay? So that should be 5. So I brought the negative down here, made it positive, and I left the ones that were positive on the top. All right, let's do another one of these. Let's just make one up. All right, we have x squared, x to the 4th, y cubed, and z to the 4th on the top, and on the bottom we have y to the 5th times z to the 7th. Let's break this down. Let's look at the x's first. The x's are multiplying to each other, so based on the laws we can add the exponents. x2 plus 4. We got y's on the top and the bottom here. For division we subtract. So y, 3 minus 5. And here again we have division with the z's, and we can subtract there as well. 4 minus 7. What does this give us? Let's add them and subtract. X, this is 6 because 2 plus 4. 3 minus 5, that's negative 2. And 4 minus 7 is negative 3. The last thing we do is anything that's negative, we just put it on the bottom. And we leave everything else that's positive, we leave that on the top. Well, x to the 6th, that can stay on the top because that's positive. Y to the negative 2, well, that needs to go down here. That needs to go down here because it's negative. And then z is also negative, so this needs to go down here as well. All right, so that covers how to do problems like this. They're all very similar to this. You just use the basic laws that were shown at the beginning of this and break each problem down into a series of those particular basic problems. In this case, we had a multiplication law here, we had 2 division laws, and then at the end, we had the negative law. All right? So that covers that. Now, let's go into the last topic of this section, which is scientific notation. Okay, let's talk about scientific notation. Here's a couple of examples we'll do for that. This is a pretty simple topic to cover. It just depends which direction we're going. You're going to have 2 particular types. One you'll have is a decimal that is some sort of number with a bunch of zeros there. And then here you'll have a large number. Like in this case, this is 12,360,000. So you have that. We have to convert them to scientific notation. Let's start with the case where it's a decimal to start with. First thing we need to do is we just need to figure out how many times we move the decimal over to get behind the first non-zero. Okay? So here's the decimal right now. I had to move it 1, 2, 3, 4 times for it to get there. So I moved the decimal 4 times. I can then write this as 3.67 times 10 to the negative 4. So when it's a decimal, your exponent is going to be negative, and it's just the number of times that it took to move to that first non-zero number. Practice a couple of these and you'll have it. It's not that much to it on this. In this case, let's look at this one. Technically, when it's a big number, there's a decimal out here that's not there, but it's implied that it's there. We don't need to put it there if it's a whole number, but it's there, and we need to put it there in this case to see how many times we have to count. 1, 2, 3, 4, 5, 6, 7. Now in this case, what we're trying to do is move the decimal to the farthest left non-zero number. We need to move it to the one that's the farthest here, the first digit basically. The decimal needs to be to the right of that, the first non-zero digit. Now we have to count how many times this happened. So we were here, this is 1, 2, 3, 4, 5, 6, and 7. So we would write this as 1.236 times 10 to the 7. Notice when it's a whole number, the number's positive. When it's a decimal, the number's negative. But it all has to do with counting the number of times that the decimal has moved to get to the position that you want it to get to. So, let's break this down real quick so you understand it one more time as a recap on it. You take the number itself, start at the decimal point. You start at the decimal point and you move it to the first non-zero digit. You move it to the right of the first non-zero digit. Okay? And you count that, and that's the number that you put there. Let's do an example of this one down here. Let's say that we have 0.036. We want to move the decimal to the right until it hits the first non-zero. 1, 2. I moved it 2 times. So this becomes 3.6 times 10 to the negative 2. Remember, when it's a decimal to start with, it's negative. So know these, 363,000. We wanted to get here. We wanted to get to the right of the first digit. Let's count how many times that takes. 1, 2, 3, 4, 5. It took 5 times. 3.63 times 10 to the 5. Okay? Just remember, the numbers that you write here are everything that you see here except the zeros. So that's what we have written here. That's what we have written here. That's what we have written here, and that's what we have written here. So that covers scientific notation, and that's the end of this section. So in the next section, we'll talk about a little more complicated problems involving division.